In this video, we're going to look at discrete random variables. A random variable is a quantity that can take any value determined by the outcome of an experiment. Let's look at what that means in layman's terms. If we take a fair coin and flip it twice, we could say the random variable x is the number of tails obtained. So we've got a random variable, and we can say x is the number of tails obtained. So the number of tails obtained. I'm using now a capital X. For our random variable, we use a capital letter. We now have x. X is all of the values that this particular random variable can take. So let's go ahead and look at a sample space. So we would have now head, head. We would have head, tail. We would have tail, head. And then we would have tail, tail. So in this case, we've got 0 tails. We've got 1 tail, we've got 1 tail, and we've got 2 tails. So we could say the particular values of our random variable, x, are going to be 0, 1, and 2. This is a discrete random variable. It can only take values on the discrete scale. So for example, we can't have 1.5 tails. It's either no tails, 1 tail, or 2 tails. So this is a discrete random variable where x is the number of tails obtained when flipping 2 fair coins, and these are the particular values the random variable can take. Let's look at the probability of this happening. So flipping a head is 1/2, flipping another head is 1/2. So if we wanted the probability, this would be 1/2 multiplied by 1/2. That's going to give us now 1/4. We would have exactly the same just here, 1/2 multiplied by 1/2, which is going to be 1/4. Here again, 1/2, 1/2, and that would be 1/4. And then finally, 1/2 multiplied by 1/2, which is 1/4. We could now look at the probability distribution of the random variable x, and we can put this in a table. Often you'll see this put in a table, and we will have particular values of the random variable in the top. So we've got x. The possible values are 0, 1, and 2. There are no other choices. We can't flip 3, we can't flip 1.5, we can't flip 0.5. It's either 0, 1, or 2. We now write the probability that x, our random variable, is equal to one of these particular values, and we write it like so. Alternative notation now is p of x. So this is an alternative, and it's slightly easier to write. So if we look now at the probability of 0 heads, that's 1/4. If we now look at probability of 1 tail, 1/4. Probability of 2 tails is going to be 1/4 plus 1/4, which is 2/4. Now, I'd like to go on and simplify that later, but I'm going to leave it in this form just for now. And then finally, the probability of 2 tails is 1/4. So x is a random variable, the number of tails obtained. X can take these values, so these are the particular values, and these are the associated probabilities. So we call this the probability distribution of the random variable x. It will come as no surprise that the sum, we can write the sum of the probability of x being equal to x is 1. We know all probabilities equal 1, and that's why I've left this now in its form here rather than simplifying it, because we can see now 1 plus 2 plus 4/4 is going to give me 1. And later on we will see that often, before fully simplifying them, it's good to write them over a common denominator, because you can see that it's going to be equal to 1. We know all probabilities equal 1, therefore we can write it like so. So this is the probability distribution. We could look at the probability function, and we could say now the probability of x being equal to x in this particular case will now be 1/4 for x now equal to 0 or 2, so x equal to 0 and 2. We could say 1/2 now for x equal to 1 and 0 otherwise. And I think this is really nice, as it clearly shows that we can only now take the values of 0, 1, and 2. So this now is called the probability distribution. So this is a distribution of the random variable, and this is the function. So there's a brief intro. So we're looking now at just listing out the associated probabilities. Okay, so let's look at the kind of questions that you might be asked. We might now be given a random variable. So let's go ahead and just jot this up. We might be given a random variable and we might say that that random variable is x. Often x is used. And we might have now x is equal to -3. We might have now -1. We might have 1. We might have 3 and 5. So these are all of the values that the function now x can take. So the probability that x is equal to x. Let's go ahead and assign some probabilities. We got 0.1, we got 0.4, let's say we've got a, we've got 2a, and let's say we've got now 0.2. So here are now the particular values of x and the associated probabilities. Let's look at some of the questions that we might be asked. We might be asked now to find the probability that x is equal to 3. We might be asked, for example, to find now the probability that x is going to be at least 1. So let's go ahead and look at solving these problems. So I want the probability that x is going to be equal to 3 and the probability that x is at least 1. The first thing we know is the sum of the probability of x being equal to x is going to be 1. So looking along here now, I can find the value of a from here. So what we've got then is 0.1 plus 0.4 plus a plus 2a plus 0.2 will be equal to 1. These all of the values that a discrete random variable can take. We know if we sum them, we're going to end up with 1. So what have we got? 0.5, 0.7. So we've got 0.7 plus 3a is going to be equal to 1. 3a is going to be equal now to 0.3. So we can see a is 0.1. So let's go ahead and do that. Let's just update this now. So this is going to be 0.1 and this is 0.2. So 0.1, 0.4, 0.1, 0.2 and 0.2 equal up to be 1. So if we now look at finding the probability that x is equal to x, and in this case x is 3, so the probability that x is equal to 3, we can see now that that is going to be 0.2. So the probability now that x is equal to 3 is now the probability associated with it, which is 0.2. Now we want the probability that x is going to be at least 1. We can say now that the probability of x being equal to 1 is equal to, and now what I'm going to say using a slightly different notation just to change things around, this will be the probability of 1 plus the probability now of 3 plus the probability of 5. So we've got now 0.1, we've got 0.2 and we've got 0.2. So we can say now that that's going to be 0.5. Now, alternatively, what we could have done is simply now 1 minus the probability of these two. So if we weren't able to, or we didn't want to find a to begin with, we could simply subtract these away from 1, knowing that the sum of all probabilities are equal to 1. I've just put some particular examples right here, but again, you can use your understanding of probability to solve these problems. Another question might be now find the probability, let's do another one, find the probability that x, our random variable, will be between, let's go for -1 and let's say 5. So we can see we've got a strict inequality here and an inclusive one here. This is the same as saying p of -1 plus now p of 1 plus p of 3. So all we're doing is considering those. So we're simply going to add those up. We've got now 0.4, we've got now plus 0.1 plus 0.2, which is now going to give us 0.7. So these are some basic questions that you might be asked when you're working with discrete random variables. Okay, let's have a look at another typical example that we might have. Let's say we've got now the probability, and we'll write this down, we'll now have a probability function. So the probability of x being equal to x will be given now, and we'll put this in. Let's choose something. Let's go for now k, then we're going to have x minus 1, and we will have now x equal to 2 and 3. We will have now, let's have another one. Let's have k, and then we'll have 8 minus x, and we will now take x, let's have x, and we'll have on this x is equal to 4, 5, and then 6, and we can say 0 otherwise. So what we want to do now is draw out the probability distribution and then find k. So what we'll do, we'll find the probability distribution and then we'll find k. So let's go ahead and do that. Now often these questions will lead you into a particular way. I'm answering them more holistically just to get some idea of what's going on. So let's now look at our values, and then what we'll have is just here the probability that x is equal to x. So straight off I can look now at subbing in 2. So I've got now 2. If I put 2 in here, that's just going to give me now k. So I can put k just here. If I put 3 in, what we're going to have now, sorry, this is just going to, let's just sub this in. If I put 3 in, let's put 3 just there. If I put 3 in, that's going to be now 2k. So we've got 2k. If I put now 4 in, remember I'm putting 4 into here, 4 will go there, now I will have 4k. So 4k is going to go there. If I put 5 in, that's going to give me 3, so let's put 5 there, we will have 3k. If I put 6 in, that's going to give me now 2k. So we know that the sum of the probability that x is equal to x is 1. What we can do is find the value of k here and then look at finding other values given these probabilities. So let's go ahead, let's add this up. So what we've got then is k plus 2k, which is 3k, 7k, 10k, 12k. So I would just show, if I was doing this in an exam, but I'm just adding these up, but these probabilities must be equal to 1 when summed. So we can say 12k will be equal to 1, that's just all of those added up. So we can say that k is going to be 1/12. So if we look at that, we can now actually write the probabilities. So if I go ahead and do that, I'll just write them below. We can see the probability that x is equal to 2 is going to be k, which is 1/12. I'm now going to have 2/12. I'm now going to have 4/12. I'm going to have 3/12, and I'm going to have 2/12. As you can see, we can quite clearly simplify these. So 1/6, we would have now 1/3, we'd have 1/4 and 1/6. But what I want to do is just check now that these do add up to give me 12/12, which is 1. So later on, go and simplify them, especially if you're giving them as your final answer. So if we were now asked to find the probability that x was equal to 5, we can just go straight for that. So we can say that that's going to be 3/12, which is 1/4. If we were asked now to find the probability that x is going to be at least 5, this is saying now that this will be probability that x is 5 plus now the probability that x is 6. So what we'd have then is 3/12 plus the 2/12, which is going to give me 5/12. So leaving it in this form, in my workings, is going to be just slightly easier rather than getting a common denominator again. But absolutely put them in their simplified form if you're doing this in an exam. So there we go, that's a brief introduction to now discrete random variables. So essentially what we're looking at is an experiment. We're looking at our experiment, we define our experiment, and we look at particular values that experiment can take. So we might have now the number of games won. So in a tournament, it might be 0 games, it might be 1 game, it might be 2 games, it might be 3 games, or it might be 4 games. That would be our discrete random variable. It can either be 0, 1, 2, 3 or 4. I can't win 2.1 games. And we would look at the probability associated with each of those particular values of the random variable. We know that the sum of all of the probabilities must be equal to 1. That's something we know before. And then we can do some basic work now, working out the value of k, or the probability that any one of these is going to happen. In later videos, we will look at the expected value, we will look at the variance, and we'll also look now at the cumulative function. So hopefully that's been a nice start for you, and then in later videos, we'll move it on from here.